Hello, in this video we're going to talk about classes. So classes are like a more complex version of functions and dictionaries combined, you might say. A class can contain several functions, and it also can contain variables which kind of act like keys. And of course the variables can have values. And so the class is typically used to represent like an object. Actually, when we make a variable that is a class type of thing, we call that variable an object. So typically these kind of objects are like you see in the real world. You have objects like cars, you have objects like, we're going to do a stopwatch here. You have objects like robots or whatever, or in a game, an NPC, non-player character. So you use a class in pretty much any situation where you want the thing that you're keeping track of, the object, to have internal state, which means it's got variables, like a dictionary has variables or keys. But also, unlike a dictionary, a class also has functions that mess with those variables. It manipulates those variables. So you want to use classes and objects when you want to keep track of something that has information about it, but also can change that information about itself. Again, this is just a way of organizing code. You don't need classes to do anything, but classes have been around since the 80s and very common strategy for programming because they really do help organize your code, even more than functions do. Because again, classes contain functions, but they also contain variables. So a class is defined with the word class, and you name it whatever, and then you can define some functions like do stuff and then print. And so to use my class, you have to actually make an object. My class is just a definition. It doesn't actually do anything yet. You have to make a variable of that type in order to use it. And then once you have a variable, which would be called an object, you can execute it. Execute the methods in the class. Oh yeah, sorry. Every time you make a class function, which is a function inside the class, right, nested inside the class, it needs to have at least one argument called self. I don't use it for this print, but you have to have the self whenever you refer to your own data. This class has no data yet, but still it has to have a self. All right, so it says stuff. Now I can make a second object. And of course, it's not going to look any different. Now, when you make a new object, what you're technically doing is executing a function called init. I didn't define a function called init in my class, so it doesn't do anything. It just has a blank init. But if I want to change some data about my class every time I create a new object, I can put stuff in this function. This function has to have the name underscore underscore init underscore underscore. And we could say self.x equals random. So just to show that my object and my object 2 have different x values, we can put the x value in the print, and when you create a new object, every time you do it, it'll get a different x value. 5 and 9, and you can see if I print again, they will retain their x values because they're holding their x values separate from each other. You have two different objects, they have two different x values. That's what self is used for. What is my x value? So when you execute a function on an object, it says do it to my data, which would be the data for this, whichever the object is. And of course, these are regular functions, so they can have arguments. So like init can have an additional argument, in which case you'd have to put it here when you execute in it. So that's the basic idea of classes. To use them in a meaningful way, let's make a stopwatch. And to do that, we're going to have to ask the computer what time it is in seconds so that we can keep track of how long the watch has been running. Now, this turned out to be a very interesting challenge for myself because I wrote this class initially incorrectly. It would be a good assignment maybe next time I teach this class for practicing with classes, because when you have a stopwatch, when you say you start the stopwatch, obviously this timer starts, and if you look at the timer, it's whatever the current time is. It'll count up 10 seconds, 11 seconds, 12 seconds, and so forth. If you stop it, you have to see what the old value is. So if you stop it at 12 seconds, every time you look at it, it should still say 12. If you then start it again, it should go from 12 to 13 to 14, and so forth. And then you want a reset option that sets it back to 0. If you reset it when it's currently off, it just goes back to 0 and it's stopped. If you reset it when it's on, it should continue counting but start at 0 this time. So there's quite a few things that are a little bit complicated in how, like, you have to get the logic right. So we'll just go through the solution here, but if you want to challenge yourself, think about how you would write this in the class. I'm going to call it class stopwatch, and then I need to set some things up. It needs to know if it's been turned on. It needs to know when the time started, and it needs to know what's the total time, because when you stop it, it should keep track of its total time. Now, this time library provided by Python will tell you the time since 1970. So it's like currently, I don't know, 10 million seconds or something since 1970. So it's not really going to tell you 0, 1, 2. So we'll have to subtract the current time right now versus the start time. That difference will be like 10 seconds. So we'll keep track of start time. Currently it's 0 because you just created the stopwatch. And then if you had stopped the stopwatch, you have to keep the total time. And currently it's turned off because you just created it. So let's make a stopwatch. We have one object. We could make multiple stopwatches, but it'd just get more complicated. My code would not change in the class, but my code down here, when I use them, might get complicated if I have multiple stopwatches. And then we're going to ask the user, what do you want to do? Ask forever. First, we'll print the status. Is it on or off? So let's make a function called status. Always has to have self if it's a function inside the class. If self is on, give back the word on. Otherwise it's off. So it'll say on or off. And blank line. And then we'll ask for, what do you want to do? You want to look at it? You want to stop it? You want to restart it? Or sorry, reset it, and so forth. Or do you want to look at the current time? If you start it, well, we should have a function called start. So let's make a start. Starting the stopwatch means the start time goes back to the current time. This is where we ask the system, what's the current time? It'll say some million odd seconds since 1970. So we record that number of seconds. And we also record the fact that we're on, so that I can say on or off properly down here. So that's starting. Elif, so else if you had said stop, well, we need a stop command also. Stopping turns it off. And we need to, because you can stop and then start it again and it keeps going, stopping should record how much time it has so far and call that total time, so that if you start it up again, it continues from total time. So we have to record that. And total time is going to be the time right now when I'm stopping it minus when I started it. And then reset will be another function. So resetting self means, let me go to my code here. This is where you clear the total time. So it could say 12 seconds, but back to 0. Now, the question is, should it start counting up again from 0 or just stay at 0? And that really depends on if it's currently on. If it's currently on, well, you kind of are doing the start all over again. So that means you reset the start time to now, and it continues counting up. So that's reset. And then lastly, I think, is the read. This is going to be a print. A function called read. So when you read the time, what that really means is you got two scenarios. If you've turned it off, it's been stopped, you reading the time is whatever the total time is. So I'll say if not self.on, else it's currently still on. It's like still counting up. So in this case, we need to take the total time that we saved from before, which might be 0 unless we had stopped it previously. Whatever we've saved before plus however much time has elapsed since the start. And if you don't type any of these commands, that means you want to quit. Before I've started it, it's just all 0 seconds. If I start it now, oops, I mistyped read. And so we're done. Now, what's important to note is these values are calculated every time you say read. It all comes from right here. So the thing is not really actively keeping track of time. Nothing happens until I type a command. And when I type the command, it then asks the system, okay, what's the current time now? And it subtracts it, and that's how long has elapsed. It's not actively keeping track of time. There's no behavior behind the scenes. But it appears to work that way, which is kind of interesting. So let's run a few more checks to make sure like reset and everything works. If I keep it on, but then I reset, see how it restarts, but it's still going up. Whereas if I stop it, it keeps, I must have typed extra space or something. It keeps the time, even though I've stopped it. That's the total time variable. And then last, we'll try restarting after we stopped it. Stop, read, same time, start up again, continues where it left off, stop, reset, but it stopped this time so it doesn't keep going, and so on. So there's the stopwatch. Again, it's simple, when it's just written out and it's explained, but to actually do these steps correctly and the whole idea of keeping track of a total time took me some time to figure out. So it'd be an interesting assignment at some point, if you want to challenge a friend or something and the friend knows Python, tell them to make a stopwatch.